interiors did most of the work. So we were basically creating a very energy efficient insulated envelope around the whole building. The first thing we did was dig up the floor, which is concrete, and put in insulation about that thick to make the floor high insulated. Then the next thing was the walls, to make very insulated walls. It's not possible to use external insulation because it's a terrace and disrupt the street scene. It was on the pavement, so it's not enough space and so on. So we used internal insulation. The problem with that is because it's so thick, it takes out a lot of floor space. So in order to make up for that, they put in a roof pod, so it gave an extra room on the second floor. Prefabricated roof pod, which was lifted into sight by a crane. So the walls were insulated firstly with blocks of highly insulating foam, and then log wool, like you have in the loft, on timber, so you could then run wires and services down through the rock wool and then plasterboard. So that lost about, I think, 10% of floor space in the rooms. Windows, we had high performance windows from gel wet, so the heat loss of the windows was about a third of what we get with normal double glazing. And one of the most difficult things was making the building really airtight, using a membrane which had to be continuous, so there were no gaps or loose joints. And to get that membrane intact and to seal everything up was one of the major challenges. Once you seal it up, you need to still provide fresh air, so we use a mechanical system which provides fresh air and also recovers the heat, so that about most of the heat you would have lost in the normal way is being recovered and fed back into the house through a heat exchanger. And we put in a modern boiler and so on. And, is it off? Okay, that's good. Put in a modern heating system and modern controls and so on. And we think we're hoping it will save about 80% of energy compared to what it had been using before. The roof pod was quite a dramatic thing to do because it involved bringing this whole triangular wedge of roof on a big lorry and then lifting it into place. And we had to reinforce the top floor to take the weight of that structure. So it was a very expensive and very disruptive piece of work to do, and this is one of the big challenges for retrofit, because people don't necessarily want their houses to be torn apart to make them energy efficient, and this is an ongoing kind of debate as to what we actually do and how far we go. This was probably the most extreme you could do, but there are intermediate steps you might do instead. We're going to be monitoring this house for the next 2 years. It's going to have tenants in. We'll be monitoring the energy use and the temperatures, but also doing interviews with the tenants to see if they understand the systems, how they find it, are they comfortable, are they too hot, and so on. And then they'll be reported back. There are 87 of these schemes, Retrofit for the Future it's called, and there are blogs and lots of information on the internet. So this is a national research project which will tell us a lot about how we go about retrofit, what works and what doesn't, and so on. So, any questions? Yeah. The cost of the project was something over £150,000, which is more than the value of the house. Clearly this is a research project, so it's not the same as rolling it out as a routine job. If you did a whole terrace, it would cost far less than a house. But it is expensive. It is many tens of thousands of pounds to go to this level of retrofit, and that is one of the huge challenges for the nation. And we have to decide, can we afford it, how do we finance it, what are the paybacks, or is it better just to use alternative heat systems like air source heat pumps or ground source heat